Inverter. Inverter.
Welcome to ClickMyProject.com. Our project title is Energy Efficiency Maximization in Mobile Wireless Energy Harvesting Sensor Networks. Abstract: in mobile wireless sensor networks, scavenging energy from ambient radio frequency signal is a promising solution to prolonging the lifetime of energy constraints in relay nodes. In this paper, we apply the simultaneous wireless information and power transfer technique to a MWSN, where the energy harvesting by relay nodes can compensate their energy consumption on data forwarding. In such a network, how to maximize system energy efficiency bits per joule delivered to relay by trading of energy harvesting and data forwarding is a critical issue. To this end, we designed a resource allocation algorithm by considering different power splitting abilities of relays under two scenarios. In the first scenario, the power received by relays is split into continuous set of power streams with arbitrary power splitting ratio. In the second scenario, the received power is only split into a discrete set of power streams with fixed power splitting ratios. For example, scenario, we formulate the resource all problem in a MWSN with Swift SWPT as a non-convex energy efficiency maximization problem. By exploiting fractional programming and dual decomposition, we further propose a cross-layer RESALL algorithm consist of sub-algorithms for rate control, power allocation, power splitting to solve the problem of efficiency and optimally. Simulation results reveals that the proposed algorithm converges within a small number of iterations and achieves optimal system energy efficiency by balancing energy efficiency, data rate, transmitting power, and power splitting ratio. In this concept is implemented using Ns2 with this paper concept. Let us see the flow of our project. First, we have to form the network. The network, we have to obtain mobile wireless sensor networks. So all the nodes are in the random mobility model. Then we have to sense the range, depends upon the clusters. For forming the cluster, then we have to obtain data forwarding by using energy, distance, and position. These are all the attributes which are used for identifying the cluster basis as well as the routing path. Then we have to choose the forwarded node, which is called the cluster node. So we have to split our network to 4 clusters. If the distance is carried, means the resource allocation using ORP protocol, that is our optimal resource allocation protocol is done here. Once the path is identified, means we have to send the data, depends on the path via the neighbor nodes. So these neighbor nodes are called the volunteer nodes. So the data transmission is done on the cluster head as well as the volunteer nodes. Then we have to analyze the performance based on throughput, packet delivery ratio, energy, and delay. Let us see the output of our project. This is our NS all-in-one 2.34 backup with VMware workstation. So this is our code folder. So now I am going to run our process. So for that we have to open terminal command line. So in that we change directory to our coding folder. So I am going to the code folder. So this is the syntax for running our main.tcl, which is mostly used in our process. So just entering this means the number of nodes set value plus k1 is nothing but the cluster head 1. So if the k1, k2 or anything else is not set, means we have to run again. So this is our energy consumption values at time. So the energy consumption versus time is displayed here. So remaining energy of each and every node is displayed. So our initial energy is taken as 100 joules. So it's now the output window is opened. I'm just clicking this play forward means it will be works. So this is the button for increasing the speed of the node. So now the base station is created, and we have to split our network into four range which is in meter. So first our network station is mobile wireless network. So for that all the nodes in mobility model, so that is nothing but the movement. So every mobile user in movement, so the cluster head is selected based upon the energy, distance and position. So this cluster head is dynamically chosen at every time of running. So now this is the node which is in the cluster 1, but it is moved to next cluster, means it will be changed to their network, like that color will be changed, and the data transmission is beginning from that particular range. Meanwhile the same process is done in the cluster 4. So which move, that is the mobile node is moved from one cluster to another cluster, and if they reach that range, means it will be get the resource allocation from that particular network. Finally it will be transformed to the destination. So this is our process for the network. So then we have to run our graph file, which is also dynamically happened. So for that we have to give xgraph space delay.xt for running our delay graph. So this is our delay graph which is in the seconds, that is times. Next graph is for throughput. So we have to achieve throughput in Mbps, that is y direction is nothing but the data rates Mbps, megabits per second, and x-axis is nothing but the time. Third one is for energy consumption ratio for each nodes. So this is our energy rate between the 100 nodes. Thank you for watching.